Good day, students. Welcome to chapter 2 of our text. We are going to deal with a three-phase electrical system. Here we are talking about having three. Initially, you can have it is possible to have one generator supplying a line whereby you have the live and the neutral. This is one generator. This one we call it a single phase. So single. Let's call a single phase. A single phase is one that is made up of one line and one neutral. And if you want to have a three-phase, that means you can have another line, another neutral, which is another single phase, and you can have another line, another neutral, which also gives another single phase. In this case, you can talk about having three different phases. This is what it used to be initially, in which case you will have to use more conductors. But as time went on, they came up with the idea of having one common neutral while we have we have three phase and one neutral, so as to reduce the number of the amount of copper conductors that will be used. So in this instance, you can have instead of having another three different neutrals, you can have only one neutral, as you have here, in which case you can have a supply, you can connect to one line and one neutral. This will give you one phase, right? This is another phase. These lines, one line and one neutral is one phase. One line and one neutral, one line and one neutral, one phase, one line and one neutral. So this is three-phase system. So this is another line. This is another line. You can tap from this line also while you have the return also from this neutral. So then also, of course, you can have when you have all these three phases, all these this line 1, 2, 3 are the three phases of the supply, and you can have it all connected together and hearted. Right. So that is a brief introduction to three-phase system. And all these three phases can be connected in different forms. They can be connected in either star or delta. But now let's talk about the advantages of this single phase system and look at the advantages of three-phase system. So determine the advantages of three-phase system over single-phase system. One of the advantages of three-phase system over single-phase system is one, that is more efficient use of copper wires. That is for distribution. That is more efficient use of copper wire for distribution. Then we have also more constant power. This you find in your textbook, and 2.2. You can look for 2.2. You find those advantages of three-phase system over the single-phase system. You have the three-phase system has another advantage of a more constant power from generator and the motor. Also, there will be more constant torque on generator and motors. Then finally, we have fewer harmonics that can generate, that can create ripples that will generate this form of eddy current, which means it will have reduced losses of heat. That is three-phase system over the single-phase system. It has fewer ripples in the direct current output when alternating current is converted to direct current. That is when you convert alternating current to direct current. You have fewer ripples, which means there won't be much heat that will be generated. Then let's talk about the phase sequence of three-phase system. The phase sequences of three-phase system. Now I am in 2.21 of your textbook. 2.21 of your textbook. The phase sequence of three-phase system. When you have, let's take this as a circuit. The voltage AB only tells you that it tells you VAB only tells you A is a higher potential, and that is why the arrow points towards A. Where the arrow points to tells you that is where the potential is higher. So if the higher potential is A, that means automatically current will flow from this I, flow from IA down to B. So VAB is the voltage across. Now, let's look at a Phasor diagram for positive phase sequence, showing phase and line voltages, taking VA as reference. If we say you should take a reference as VA, that means VA is taken to be at 0, at angle 0, if it's the reference. So now when we talk about the positive phase sequence, if it's a positive phase sequence, it only tells you that if this is VA, this is VB, and VB will be at angle minus 120 degrees because they are separated by 120 degrees apart from each other. While this one will be VC at angle 120 degrees. It will be 120 degrees, then get here to 40 degrees. Of course, when you take it out from 360, this one will be on the positive side, which is 120 degrees. This is a ABC. We call it ABC, or positive phase sequence. Then when you have this as VA, if it is positive phase sequence, this VA means it is phase voltage. We represent phase voltage by only one subscript, or we say VA or VAN. This is a phase voltage. Whenever you see VA single subscript or VAN, it is a phase voltage. So you can have VB also is a phase voltage, or you can be VBN, VC also, or VCN. Right. The line voltage will always be two subscripts, which is AB, BC, or CA. So when we look at this as it is, because it is positive phase sequence, the line voltage will lead the phase voltage by 30 degrees. In a positive phase sequence, the line voltage leads the phase voltage by 30 degrees. So What is the phase voltage here, VA? VAB, because it normally follows AB, BC, and CA. Right. That is the positive notation. So our VAB is the line voltage for this. So, and it leads this by 30 degrees. So this will be our VAB at angle 30 degrees. That is our line voltage. VAB is our line voltage. So the line voltage of this one automatically leads it by 30 degrees. So if this is VC 120, our VCA will be at angle 150 degrees. Right. So if this is also VB, our VBC also, which is the line voltage, will our VB is at angle minus 120 degrees. So our VBC will be at angle minus 90 degrees. All 30 degrees apart from their respective phase voltages.